Good morning, my dear students. In the previous class, we discussed how to calculate oxidation number. In this class, I am going to discuss what is oxidation and what is reduction and what is redox reaction. Let us discuss what is oxidation. See, there are so many definitions for oxidation. First one, loss of electrons is oxidation. Loss of electrons is oxidation. Example, sodium lost one electron and form one Na plus. Sodium lose one electron and forms Na plus ion. This is oxidation. Loss of electrons is oxidation. Magnesium, it lose two electrons and form Mg2 plus. Mg2 plus. So Mg2 Mg2 plus, this is oxidation because loss of electrons is oxidation. Second one, increase in oxidation state. Increase in oxidation state also oxidation. For example, sodium convert into Na plus. Here sodium oxidation state 0. Why? Because this is uncombined state, free state, so 0. And Na plus, here oxidation state plus 1. So 0 to plus 1, oxidation state increases. That's why this is oxidation. For example, Mg2 Mg2 plus. Here magnesium oxidation state 0. Here magnesium oxidation state plus 2. 0 to plus 2, oxidation state increases. So oxidation state increases also oxidation. Okay, or loss of electrons is oxidation. Next, third one, addition of oxygen atoms. Addition of oxygen atoms is also oxidation. For example, C plus O2 is gives rise to CO2. Here two oxygens added to carbon. So here carbon undergo oxidation. Mg plus O2 is gives rise to MgO. Here oxygen is added to magnesium. So magnesium undergo oxidation. So addition of oxygens is oxidation. Next one, removal of hydrogens. Removal of hydrogens. Removal of hydrogens also oxidation. For example, H2S plus Cl2 is gives rise to 2HCl plus S. See here in H2S converted into sulfur. Here two hydrogens removed from H2S. That's why removal of hydrogen also oxidation. So H2S to S, oxidation, because two hydrogens removed from H2S and converted into S. So this is also oxidation. Addition of oxygen atoms, oxidation, or removal of hydrogen atoms, oxidation. Now coming to the next one, reduction. What is reduction? What is reduction? Complete opposite of oxidation definitions. Loss of electrons, oxidation, then gain of electrons, reduction. Example, gain of electrons. Gain of electrons, reduction. For example, Cl plus 1 electron is gives rise to Cl minus. Here chlorine gain 1 electron and converted into Cl minus. So this is reduction, gain of electrons. Or decrease in oxidation state. Decrease in oxidation state, also reduction. For example, O2 is gives rise to O2 minus. See this, here oxygen oxidation state 0, here oxygen oxidation state minus 2. So 0 to minus 2, oxidation state decreases. That's why this is reduction. Mn plus 7 to Mn plus 2. Mn plus 7 to Mn plus 2. Here oxidation state plus 7, here oxidation state plus 2. So decrease in oxidation state. So decrease in oxidation state, reduction. Okay. Next one. Here addition of oxygen atoms is oxidation. Removal of hydrogens, oxidation. Reverse. Addition of hydrogen atoms. Addition of hydrogen atoms. Addition of hydrogen is oxidation. Sorry, addition of hydrogen, reduction. Example, H2 plus Cl2 is gives rise to 2HCl. Here chlorine hydrogen added to chlorine. So here hydrogen added to chlorine, that's why addition of hydrogen is reduction. Cl2 to HCl, reduction because hydrogen added. Okay, next one. Last one, removal of hydrogen, oxidation. Here removal of oxygen, oxidation. Removal of oxygen atoms or oxygen. Example, CuO. For example, CuO converted into Cu. This is reduction because oxygen removed from CuO. CuO to Cu. This is reduction process. Removal of oxygen, reduction process. Okay now? Let us discuss what is oxidizing agent and what is reducing agent. See, oxidizing agent. Or oxidant. Oxidizing agent or oxidant. Next, reducing agent or reductant. Reducing agent or reductant. See, the substance which undergo oxidation is called reductant or reducing agent, and the substance which undergo reduction is called oxidant or oxidizing agent. Okay, which undergo oxidation, that is reducing agent, which undergo reduction, that is oxidizing agent or oxidant. See one example, Mg plus O2 is gives rise to MgO. Here magnesium oxidation state 0, uncombined state. In O2, oxygen oxidation state 0, uncombined state. In MgO, this is a combined state. Here magnesium oxidation state plus 2. Why? Because this is second year group element. Second year group elements oxidation state plus 2. Oxygen oxidation state minus 2. See, 0 to plus 2. 0 to plus 2. 0 to plus 2, oxidation number increases. That's why this is oxidation. Oxidation. And O2, 0. Here O2. Minus 2, 0 to minus 2, oxidation number decreases, that's why reduction. Increasing oxidation state, oxidation, decreasing oxidation state, reduction. Now tell me, which undergo oxidation? Which undergo oxidation? Mg undergo oxidation, that's why this is reductant or reducing agent. Oxygen undergo reduction, that's why this is oxidant. Now oxidant is oxidant O2, reductant is Mg. Mg undergo oxidation, that's why that is reductant or reducing agent. O2 undergo oxidation, that's why that is O2 undergo reduction, that's why that is oxidant. Which undergo oxidation, that is reductant. Which undergo reduction, that is oxidant. Okay, in this reaction magnesium reductant, O2 oxidant. Okay, so this is the definition for oxidant and reductant or oxidizing agent or reducing agent. Okay, next one, redox reaction. What is redox reaction? The chemical reaction in which both oxidation and reduction takes place, called redox reaction. Redox reaction means in that reaction both oxidation and reduction reaction takes place. For example, Mg plus O2 is gives rise to MgO. Just now we discussed. Here Mg2 plus oxidation, O2 to O2 minus, reduction. So this is an example of redox reaction. Why? Here both oxidation and reduction takes place. That's why this is an example of redox reaction. Okay, let us discuss types of redox reactions. There are different type of redox reactions. First one, combination reactions. Second one, decomposition reactions. Third one, displacement reactions. Fourth one, disproportion reactions. Fifth one, comproportion reactions. Let us discuss each and every one. First one, combination reactions. Combination. Combination reactions. What is combination reaction? Two elements combine to form a single compound, that is combination reaction. For example, A and B combine to form AB. This is combination reaction. In this one element undergo oxidation, another element undergo reduction. For example, C plus O2 is gives rise to CO2. This is a combination reaction. Now check. Here carbon oxidation state 0. Why? Uncombined state. In this one oxygen oxidation state 0 because uncombined state. In CO2 carbon oxidation state plus 4. Oxygen oxidation state minus 2 because those are combined state. Now check 0 to plus 4. Oxidation because oxidation number increases 0 to plus 4. Here 0 to minus 2. 0 to minus 2. Oxidation number decreases. That's why reduction. Reduction. Oxidation number decreases. Reduction. So in this reaction both oxidation and reduction takes place. That's why this is a redox reaction. In redox reaction, what type of redox reaction? Combination reaction. Because two elements combine to form a single compound. So this is a combination reaction. One element undergo oxidation, another element undergo reduction. Okay. One more example. Mg plus O2 is gives rise to MgO. This is also combination reaction. Magnesium undergo oxidation because Mg to Mg plus 2. O2 0 to minus 2 reduction. Next H2 plus Cl2 is gives rise to 2HCl. This is also combination reaction. Here H2 0 and Cl 0. In this one hydrogen plus 1, chlorine minus 1. 0 to plus 1 oxidation, 0 to minus 1 reduction. So both oxidation and reduction takes place. That's why this is an example of redox reaction. In redox reactions, what type of redox reactions? Combination reactions. Two elements combine to form a single compound. So in those, one element undergo oxidation, another element undergo reduction. Okay. Next one. Second one. Decomposition reactions. What are decomposition reactions? Generally, these are reverse of combination reactions. In the combination reaction, what happened? Two substances combine to form a single compound. Here reversal. So one single compound dissociate and gives two or more substances. That is called what? Decomposition reaction. That means decomposes. Example, H2O is gives rise to H2 plus O2. In this one, hydrogen oxidation state plus 1, oxygen oxidation state minus 2. In H2, hydrogen oxidation state 0, oxygen oxidation state 0 in O2. Why? Because they are uncombined. In this one, not 0. Why? Because they are combined. Hydrogen oxidation state plus 1, oxygen oxidation state minus 2. Already we know. Okay. 2H2 which gives rise to 2H2 plus O2. Balancing. Now, hydrogen plus 1 to 0. Plus 1 to 0. Oxidation number decreases. That's why reduction. Minus 2. Minus 2 to 0. Oxidation number increases. Minus 2 to 0. That's why oxidation. Oxidation. Okay. So, this is an example of decomposition reaction. One substance decomposes and gives two or more substances. That is called what? Decomposition reaction. One more example. KClO3 is gives rise to 2KCl plus 3O2. 3O2. This is also example of decomposition reaction. Here, potassium oxidation state plus 1 because that is a 1A group element. 1A group element oxidation state plus 1 in their compounds. Chlorine, in this chlorine oxidation state plus 5. Oxygen oxidation state minus 2. In this one, potassium does not change. Oxidation number plus 1. Chlorine oxidation state minus 1. Why? Because K plus to Cl minus. Oxidation state of chlorine minus 1. In this one, oxygen oxidation state 0. 0. Now plus 5 to plus 5 to minus 1. Plus 5 to minus 1 reduction because oxidation number decreases. Reduction. Next, minus 2 to 0. Minus 2 to 0. Oxidation number increases. That's why this is oxidation. So this is an example of decomposition reaction, and this is also redox reaction. Why? Because both oxidation and reduction takes place. So what type of redox reaction? Decomposition redox reaction. Okay, KClO3 decomposes, gives KCl and O2. Okay, so in this one, Cl plus 5 to minus 1 reduction, oxygen minus 2 to 0 oxidation. Got it? So this is decomposition reaction. Next, third one, displacement reaction. See, in this, for example, Zn plus CuSO4 is gives rise to ZnSO4 plus Cu. See, here what happened? Zinc displaces copper. Here Zn oxidation state 0. Why? Because uncombined state. In CuSO4, copper oxidation state plus 2. Why? Because it dissociates as Cu plus 2 and SO4 2 minus. SO4 2 minus. So copper plus 2. In this one, Zn oxidation state plus 2. Why? Because Zn it dissociates as Zn2 plus and SO4 2 minus. So Zn oxidation state plus 2. Here copper oxidation state 0. Uncombined state 0. Okay. Now see, 0 to plus 2. Oxidation. Plus 2 to 0. Reduction. This is oxidation and this is reduction. 0 to plus 2 oxidation and plus 2 to 0 reduction. So this is also redox reaction. In redox reaction, what type of redox reaction? Displacement reaction. Okay, one more example. KCl plus F2 is gives rise to 2KF plus Cl2. See here, chlorine oxidation state here -1. In this one, fluorine oxidation state 0 because uncombined. In this one, fluorine oxidation state -1. In this one, fluorine oxidation state 0. Here what happened? Fluorine replaces chlorine. That means fluorine displaces chlorine. So it gives KCl gives KF with F2. Here what happened? Fluorine displaces chlorine and gives KF. Here chlorine -1 to 0. Oxidation. Here fluorine F2 0 to -1. Reduction. So this is also example of redox reaction. In redox reaction, what type of redox reaction? Displacement reaction. Okay, displacement means one element replaced by another element. Okay, next one, disproportion reaction. Disproportion reaction. What is disproportion reaction? Disproportion reaction means in this type of redox reaction, same element undergo oxidation and reduction. Same element. Before we discussed different type of redox reactions. In those, one element undergo oxidation, another element undergo reduction. But in this type of reaction, same element undergo oxidation and reduction. Example. MnO4 minus 2 plus H plus is gives rise to MnO4 minus plus Mn plus 2 plus H2 MnO4 4H plus 2H2O. Okay. MnO2. Okay, now see this reaction. In this one, manganese oxidation state plus 6. Manganese oxidation state plus 6. In this one, manganese oxidation state plus 7. In this one, manganese oxidation state, in MnO2, manganese oxidation state plus 4. See, plus 6 to plus 7, oxidation. Again, plus 6 to plus 4, reduction. Here what happened? Same element, manganese undergo oxidation and manganese undergo reduction. Same element undergo oxidation and reduction. That's why this is example of disproportion reaction. What is disproportion reaction? Same element undergo oxidation and reduction, called disproportion reaction. One more example. See, P4 in basic medium, it gives PH3 and H2PO2 minus. In P4, what is the oxidation state of phosphorus? 0. Why? Uncombined state. In pH3, what is the oxidation state of phosphorus? -3. Why -3? 1 hydrogen oxidation state +1, 3 into +1 +3 is equal to 0. Send right side, then -3. Already we calculate. How to calculate oxidation number? H2PO2 minus. In this one, phosphor oxidation state +1. Check 0 to -3. 0 to -3, oxidation number decreases. That's why that is reduction. And again 0 to +1. 0 to +1, oxidation. So same element undergo reduction and undergo oxidation. So this is an example of what? Disproportion reaction. Disproportion reaction means same element undergo oxidation and reduction. Okay, now one more example. See this, Br2 plus 3Br2 6OH minus is gives rise to Br minus plus BrO3 minus plus H2O 3H2O. Okay, see this reaction. In this one, bromine oxidation state 0, uncombined state. Here bromine oxidation state -1. Here bromine oxidation state +5. How we get +5? Bromine plus 3 into -2 is equal to -1. Charge -1. So bromine -6, send right side +6, +6 -1 +5. Okay, bromine oxidation state +5. Here 0 to -1, 0 to -1, oxidation number decreases, so reduction. And again 0 to +5, 0 to +5, oxidation number increases, that is oxidation. So same element undergo oxidation and reduction. So this is called what? Disproportion reaction. Okay, and the last one is cum proportion reaction. Last one, cum proportion. Cum proportion means that is the reverse of disproportion reaction. Reverse of disproportion. In disproportion, what happened? Same element undergo oxidation and reduction, but in cum proportion, same element in different oxidation states combine to form intermediate oxidation state product. For example, Az plus 2 plus Az is gives rise to Az plus. See this reaction, same element in different oxidation state, here +2, here 0, gives a product which has intermediate oxidation state. Intermediate oxidation state, that means this oxidation state in between 0 and +2. Okay, so this is cum proportion. See the reverse reaction, +1 to 0 reduction, +1 to +2 oxidation. Okay, so this is the reverse of cum proportion reaction, means reverse of disproportion reaction. Disproportion reaction means same element undergo oxidation and reduction. Cum proportion means same element in different oxidation states. Okay, gives a product which has intermediate oxidation state. Got it? So this is cum proportion reaction. +2 to +1 reduction, 0 to +1 oxidation. So these are the types of redox reactions. Okay, in the next class we will discuss how to balance the redox reactions in acidic medium and alkaline medium. Okay, thank you.